All right, we're going to look at special right triangles. Now, special right triangles is really a useful tool to make your job of figuring out things about right triangles faster. All right, so in this situation, we're going to look at first off 45, 45, 90 triangles. 45, 45, 90. Now, these triangles are basically like a square cut from corner to corner, if you can think about it that way, because the angles are going to be 45 degrees and 45 degrees. And then our parts are going to be a hypotenuse and then two legs. Now, since it's basically half of a square, the first thing that we can know for sure, if we look at a problem like number 4, is that the legs match. So if this is 3, then B has to be also equal to 3. All right, so that's a quick step. Next, the hypotenuse, if we use Pythagorean theorem here, we would do a squared plus b squared equals c squared. Okay, so let's go ahead and do that. That would be 3 squared plus 3 squared equals c squared. And then that would be 9 plus 9 equals c squared, or 18 equals c squared. Then we would have to square root both sides. We get c equals the square root of 18. Well, but that simplifies. That's the same thing as the square root of 9 times the square root of 2. Because 9 is the largest perfect square that multiplies to get 18, and 9 times 2 equals 18. The square root of 9 is 3, and then we bring down our square root of 2. Now that is our final answer. And it takes a minute. But every single time I do this problem, whatever I square here and square here, like this, and add them together, I'll end up with 2 times that number. And so every time I'll be able to simplify it as the square root of that times the square root of 2. So what that means is that I can always take a 45, 45, 90 triangle, and if I know one of the legs, the other leg matches, and then the hypotenuse will always be that leg length times square root of 2. All right, so for instance on number 8. So number 4 took us a minute, but number 8, if this is 7, then this side is 7, this side is 7 square root of 2. It just always is. So that's our rule for 45, 45, 90s. We look at our triangle, and whatever our legs are, they both match each other. So we'll call a leg of our right triangle a 45, 45, 90 triangle. We'll call the leg X. Whatever that leg is, the other leg matches, and always the hypotenuse is that leg length X times square root of 2. So anytime we're given an integer leg length, then that means our problem can be done very quickly. So try problem number 5. Try this problem. Pause it for a minute and try 5 for me. Okay, so if you tried 5, we are given a leg length of 1, so that means this leg length is also 1. Make sure you got that. Okay, now the hypotenuse will just be 1 times square root of 2, but you would never see it written that way. You would just see it square root of 2. That's it. So sometimes we may have a little tougher problem. So let's say, like on problem number 2, we've got a non-integer leg length. That's all right, we can still do it. It's just going to have to take a little bit of simplifying with radicals. So if this is 4 square root of 2, then this is 4 square root of 2, and then the hypotenuse has to be this number times square root of 2. So that will be 4 square root of 2, that's like our x value, right, times square root of 2. Well, when we simplify that, we just multiply our radicals, and we get 4 square root of 4, but that is 4 times 2, which is 8. So 8 is our hypotenuse length, and our other leg matched. All right, let's try one like that. Everyone try number 7 for me. Pause this and try 7. Okay, so if you tried 7, we've got our leg length is 3 square root of 2. Leg length is 3 square root of 2 because it matches. And then the hypotenuse is 3 square root of 2. That's like our x value, right? That is that times square root of 2. Just like what we did last time. Well, that square root of 2 times square root of 2 is square root of 4. square root of 4 is regular 2. So this is going to be 3 times 2, which is just 6. So our hypotenuse there is 6. All right. Sometimes we will be given the hypotenuse. And if the hypotenuse is in the right format, then it's still going to be a pretty quick problem. We want the hypotenuse to be something times the square root of 2. That is our preference. So let me look around for a problem. It looks like I don't see... Oh, here's one. All right, number 13. This has got the hypotenuse given, and it says 8 times the square root of 2. Well, if we remember our basic triangle where we have got 45, 45, 90, and we know that this is x, and this is x square root of 2, this is in the form x square root of 2. If the leg length are equal to, if the leg lengths are equal to x, and this is like x square root of 2, then 8 has to be our x value. So both legs are going to be equal to 8. Okay? And so let's try, let me have you try a problem. I'll make one up real quick. So let's say I've got a 45, 45, 90, and the hypotenuse is 5 square root of 2. So go ahead and pause me and figure out the leg lengths. All right, so the leg lengths, this is in the form x square root of 2, so the leg lengths will be x and x are just 5 and 5. All right, so those are the most basic problems. They get more complicated than that, but everything beyond that is just a matter of simplifying radicals when you work with them. So for instance, if we look at problem number 10. 10 has got a leg length with a radical, but the radical is not 2. So we still deal with it the same way. We say this leg matches at 4 square root of 3, and then the hypotenuse is going to be this amount times square root of 2. So that's 4 square root of 3 times square root of 2. Well, square root of 3 times square root of 2 is just square root of 6, and it doesn't simplify. It is just 4 square root of 6, and that's your hypotenuse length. That's it. All right. Let's see if there's another one like that for you to try. I don't see one right now, so I will make one. Let's say we've got a problem like this, and I tell you that this is a 45, 45, 90, and that this leg length here is 3 square root of 5. Then go ahead and try to find out this leg and then the hypotenuse. Pause it and try it. Okay, this leg length is 3 square root of 5, so this one is also 3 square root of 5. And then the hypotenuse will be 3 square root of 5 times square root of 2. Well, that's just going to be 3 square root of 10 because we multiply 5 and 2 in the square root. And that's it. So that's your intro on 45, 45, 90 triangles. Try some of them. Let me know if you have any questions.